You know, for as long as we've been around, we've been trying to find some kind of order in all the chaos, right? We're looking for the rules, the patterns that make the world tick. And for thousands of years, one thing more than anything else has been the key, and that's mathematics. It's like the language the universe itself is written in. I mean, think about it. Day turns into night, the seasons change, animals know when to migrate. Seeing these patterns isn't just a neat trick, it's a basic survival skill. Even animals get it. They have a sense for numbers and distance. They know when the herd is smaller or if a predator is getting a little too close for comfort. For them, it's literally the difference between life and death. But we humans, we took those basic instincts and built something absolutely extraordinary on top of them. We didn't just see the patterns. We started counting them, measuring them, and finding the connections between them. So this is that story. We're going to take a journey back in time to see how this incredible universal language was born. Okay, so our first stop is ancient Egypt, a civilization literally built around the River Nile. And for the Egyptians, the biggest event of the year was the annual flood. Now, this was a chaotic, destructive force, yeah, but it also brought the rich soil they absolutely needed to grow food. And all that chaos created a bunch of very real, very practical problems that needed, you guessed it, mathematical solutions. See, for the Egyptians, math wasn't some abstract thing you did in a classroom. It was all about survival. How do you predict the floods? You need a calendar. How do you tax farmers fairly when their land gets washed away and redrawn every year? You need to measure it precisely. And as their society got bigger, well, you just can't run a massive state without a way to count and calculate everything. Math was a tool, plain and simple, born out of pure necessity. So, to solve all these problems, they came up with a number system. It was base 10, kind of like ours, but let's just say it was a bit clunky. They didn't have a system for place value, so writing big numbers was a real chore. Get this, to write the number 1,234,567, an Egyptian scribe would have had to draw 28 separate symbols. It worked, sure, but man, was it inefficient. But even with their clunky numbers, they were brilliant problem solvers, especially when it came to multiplication. Their method was just genius. It was all based on doubling. So say you want to multiply 6 by 3. You'd find the powers of 2 that add up to 6, so that's 2 and 4. Then you just add up the corresponding doubles of 3, which are 6 and 12, and boom, you get your answer, 18. It's such a clever workaround, and it tells us something amazing about how they thought. And here is the truly mind-blowing part. Without even knowing it, the Egyptians were using binary code. By picking 4 and 2 to make 6, the scribe was basically writing 6 in binary, 1 4, 1 2, and 0 1s. This is the exact same on-off, yes-no logic that powers every single digital device we use today. Your phone, your computer, all of it. Its roots are right here in ancient Egypt. Their practical genius also led them to a remarkably accurate value for pi. They needed to figure out the area of their circular fields for farming, right? So they worked out that a circle with a diameter of 9 had about the same area as a square with a side of 8. That simple rule of thumb gives you a value for pi of 3.16, which is less than 1% off the real value. That is just incredible for that time. All right, so the story of math is always building, one civilization learning from the last. So our journey now takes us east to Mesopotamia and the mighty Babylonian Empire. Now, they had different problems. They were running a huge territory, and they were obsessed with mapping the stars. And for that, they needed a much more powerful number system. While the Egyptians used base 10, probably from our 10 fingers, the Babylonians used a base 60 system, and they had this really clever way to do it using just their hands. They would count the 12 knuckles on 4 fingers using their thumb, and then they'd keep track of how many sets of 12 they counted using the 5 fingers on their other hand. 12 times 5 gives you 60. And this system was so good, so powerful, that its legacy is still with us. Every time you look at a clock, 60 seconds, 60 minutes, that's Babylonian math right there. But a powerful system like base 60 needs something called positional notation, and that creates a big problem. What do you do when a position is empty? How do you write the number 601 versus 61? The Babylonians' answer was revolutionary. They invented a symbol, a simple wedge, to be a placeholder for nothing. It was the very first zero in human history, a conceptual leap that just unlocked the ability to do incredibly complex calculations. And if you want to see just how good they were, you have to look at this ancient clay tablet, Plimpton 322. It's almost 4,000 years old, and it's basically a cheat sheet. It lists 15 perfect Pythagorean triangles, triangles where the sides all fit that famous a squared plus b squared equals c squared rule. This is just stunning. It's proof that the Babylonians understood this principle more than 1,000 years, 1,000 years before Pythagoras was even born. And that brings us to ancient Greece. This is where the story takes a massive turn. The Egyptians and the Babylonians, they were masters of practical math. They knew what worked. But the Greeks, they were different. They were obsessed with a new, much deeper question. Why does it work? And that obsession led to maybe their single greatest contribution, the whole idea of proof. The idea that a mathematical truth isn't true just because it seems to work for a few examples. No, it's only true if you can logically, step by step, prove it from a set of basic starting points, or axioms. This is what gives math its special power, its absolute rock-solid certainty. Let's go back to that Pythagorean theorem. The Greeks weren't happy just knowing it was true. They had to prove it with pure logic. And their proof? It's just beautiful. You just rearrange 4 identical triangles inside a big square. And by doing that, you can show, with no numbers, just looking at it, that the area of the big square on the longest side has to equal the areas of the 2 smaller squares. It's just flawless, elegant reasoning. This way of thinking was so powerful, it led the Pythagoreans to believe that the entire universe was literally built from whole numbers and the simple fractions you can make from them. They thought everything, from the harmony in music to the orbits of the planets, could be explained by this idea that all is number. But here's the beautiful, cosmic irony. What happens when your most powerful theorem, the very foundation of your philosophy, ends up revealing something that completely shatters your most sacred belief? When one of the Pythagoreans used the theorem on the simplest right triangle you can imagine, one with 2 sides of length 1, they found the longest side was the square root of 2. And this number, this was a catastrophe. It wasn't a whole number. You couldn't write it as a simple fraction. It was a totally new kind of number, one that goes on forever and ever without repeating. It was irrational. And this discovery just shattered their worldview. But it also blew the doors wide open to a huge undiscovered continent of mathematics. So, from the down-to-earth calculations on the Nile to these intense philosophical debates in Greece, we've watched math grow up. It transformed from a simple tool for survival into this deep, profound way of looking at the entire universe. You can really see the evolution here, can't you? The Egyptians needed practical math just to get by. The Babylonians built a more sophisticated system to run an empire and study the stars. And then the Greeks came along and gave us abstract logic and proof, turning math into the powerful science we know today. But this is only the beginning of the story. These ancient civilizations laid all the critical groundwork, but the next great leap in our mathematical odyssey, that would happen in the East, with the invention of algebra and a whole new way of thinking about numbers. But that, of course, is a story for another time. It just goes to show you that math isn't some dusty old subject. It's a living, breathing story of our endless quest to understand everything.